Hi guys, this is Reshwant and you're watching Side Tutorials. Hope you guys are doing very well. And in this video, we are going to discuss about floating point representation. In the previous video, we discussed how integer data type will be stored in the memory architecture, right? So in this video, we will see how the floating points, how the decimal points will be stored in the memory architecture. So in Java, the decimal values will be separated by two data types. So one is float, second is double. For float, we have to for float, it consumes 4 bytes of space, and for double, it consumes 8 bytes of space. Okay, and this is the examples for the float and double. So now we will see how we need to convert the decimal number into binary, and that binary, how we can store that binary into a memory architecture. Okay. So for that, we have some standards. So why we need to follow these standards? Because for normal number, we can convert the number into binary, and we can store in bytes. But here we have some symbol, like we have some dot here. Okay, so that's why we can't represent this dot in binary format, right? That's why like we need to follow some steps, because if I follow my own steps and someone will follow their own steps, okay, and it will so at last everything will be collapse. Some classes will be happen. That's why we have for everyone there will be some common standards will be needed. That's why we have some standards which is provided by the Institute of Electrical and Electronics Engineers. So they have a lot of standards, and for this for this floating point, we have the standard number 754. Okay, and we will see with this example. So first we took the value of 28.125, and we need to convert this value into binary, because the computers only understand the binary language. So if it's a normal number, like if it's a normal integer, we can convert this value into binary by simply doing LCM. But this is having decimal. Okay, that's why we need to do some operations. Like first we need to split the number into two. So one is whole number, second is decimal number. So I split the number of 28.125 into two. One is 28, second is 0.125. And this, because this is a whole number, I can perform LCM, and I can get the binary values, right? Binary format. I'm doing LCM here, and here we are doing the here we are doing the conversion from the decimal to binary. That's why we need to use 2 here for the division. So I did a division here, and I got the 0 as a reminder. And in the second step again I got 0. And in third step I got 1 as a reminder. And fourth step again 1. And at last I end up with 1 here. So we can't divide 1 with 2, right? That's why this still we stop the process here. And to to get the binary format, we need to traverse from the bottom to top here. Okay, that's why here we see 1 1 1 0 0. Okay, so here this is the binary format for the 28. Okay, and here we have 0.125. So how we can convert this 0.125 into binary. So for this like it will be very different. Because we need to perform the division part left side of the decimal. Okay, and right side of the decimal we need to perform multiplication. Okay, that's why what we done is we took the value 0.125 and we multiply the value with 2, and we got 0.25. Okay, and here we need to store the value of decimal. Okay, so here we have 0, that's why I kept 0 here. Again I took the same value 0.25, and again I multiply with 2, and now I got 0.5. Again I stored this 0 here. Okay, and again I took this value 0.5, and again I multiply with 2, and I got 1. So after decimal, I don't have any value here. That's why I stopped the process, and I stored the one here. So during the LCM, what we done is we traverse from bottom to top, right? Here, what we have to do is we have to traverse from top to bottom. Okay, that's why here the values are 0, 0, 1. Okay, so this is how we can get the values. And here, if you see, for so the binary value for the 28 is 11100, and for binary format for the 0.125 is 0.001. Okay, and now we have to combine. So the binary format for the 28.125 is 11100.001. Okay, and here we have to keep 0, yeah, we have to keep 0 dot. Okay, because these are the decimal values. So now we successfully convert the decimal value into binary format. Now we will see how to store this value in the memory architecture. For that, we need to use the normalized we need to use the normalized form. So what is meant by normalized form? So the IEEE 754 standards have mentioned one defined structure of the value for the binary. So we need to convert our result into that format. So so this is the format they given. So they asked to convert the any value in this format. One point some any number, I mean any numbers into 2 power n. Okay. So this is our value. We got the value 111.001. Okay. So to convert this value into this form, what we have to do? Simply we need to shift this point to left hand side. Okay. For that, we can use simply 1.11000001 into 2 power 4. And why we have to use 2 power 4? Because if in decimals, if you want to shift any value, I mean if you want to shift the decimal towards the left side, what we'll do? We simply use 10 power 1, 10 power 2, 10 power 3. Later we use, right? The same way, this is binary format. That's why we need to use 2 power 4, 2 power 5, 2 power 6. Later we need to use. Okay. And here, this is the format we got. And in third step, we have. And what is that step? So we have some IEEE 754 fields. We have to fill this value in those fields. Okay. So what are those fields? So there are total three fields they have mentioned. One is sign. So we have first is sign. So this sign represent either the number is positive or negative. And second is exponent. Third is we have mantissa, or we can say significant. So we will see one by one. So as I know, this is a positive number, right? That's why I can keep 0 in this sign bit. Okay. If for the positive it's 0 and for negative it's 1, and we have exponent. Okay. And for it, because I'm doing this operation for the float. Okay. So we have some standards, like for the float we have to keep 8 bits for the exponent. Okay. So that's why I like leave it 8 bits here. Okay. And then we have to fill the mantissa. So what is mantissa here? The value which is there okay, after the decimal. So this is nothing but a mantissa. Okay. So I fill this value here, double one triple double zero double zero one. Okay. And I have remaining bits, right? Because float has 4 bits. It means 4 bytes, right? So 4 bytes means 32 bits. So this is 1 bit. Here I am leaving 8 bits. Okay. And remaining uh, 23 bits will be there. Okay. So those 23 bits here, I kept some values here, and the remaining values should will be filled with zeros. Okay. And here now we kept the signature and we fill the mantissa value. So now how to do, like what value I have to keep in the exponent, we will see. So for the exponent, what the exponent will here will indicates. So this indicates the position of the decimal point. Okay. How it will be. So how I can fill this value, we'll see. For that, for the float, it is we have to keep 8 bits. Okay. This is the bias value we say. And for double, it is 11 bits. Okay. So the like we can I can explain this why only 8 bits for the float and why 11 bits for the double, but it will take long time. Okay. So just remember, for the float it will take 8 bits, and for double it will take 11 bits. Okay. And in the 11, I mean in the 8 bits, how many combinations you can go? So if you are good at mathematics and by doing permutations, we can get 2 power 8 values. Okay. And in 2 power 8 we have 0 included. So the number starts from 0. That's why the total values will be 2 power 8 minus 1 equal to 127. Okay. The same way for double also. For double it is 11 bits. That's why 2 power 11 minus 1, and which is something but 1023. Okay. And now we have to take this 127. Sorry, I did a mistake here. So for 2 power 8 minus 1, it will get around 255 or something, I guess. For 255, what will happen is we can move the decimal point either right side or left side, right? So that's why we need to we need to split the value into two things. So suppose this is the line, and we need to split the value into two. Okay, that's why we can have 126 here and here 127, and in the middle we have 0, and this is negative. If it's 0, like decimal is in the center, I can say. Or if it's negative, the decimal is moving towards the right side. And if or else if the it's positive, the decimal is moving, I mean decimal point is moving towards the left side. Okay, like, so like that I can say. So what, so now in the for float it is 128, I mean 2 power 8 minus 1, right? So what can be the maximum value? So the maximum value will be the 127. So we'll take 127 here. And so in the while converting while moving the decimal point, we got 2 power 4, right? So here we got 2 power 4, right? So that's why we need to use this 4 here. Okay, so what we are doing here is we have to take order 127, which is bias the value, which is bias value, plus we need to add the 4 value. Okay, like at last we got 131, and this 131 will be converted into binary format, and this binary value will be stored in the exponent. Okay, suppose if I move the point decimal point here towards the right side. Okay, that time I got the minus 4. Okay, so so that time we need to use 127 minus 4. That time it will get 123. So after converting that 123 into binary, we need to fill the value in the exponent place. Okay, that's how the floating values will be stored in the memory architecture. So here you can say for float we have totally 32 bits, which means 4 bytes, right? So in the 4 bytes, it consumes 1 bit for the sign, and remaining 8 bits for the pointing. I mean, representing the position of the decimal point. Okay, and remaining 23 bits only we are using to store the value of the float. That's why we need to use 2 power 23. Okay, and we are here we are finding the minimum value, that's why we are using minus 23. And in the mantissa, I mean in the exponent, by with the help of the position of the pointer, we can have multiple values like 1.23, 12.3, 0.123, like that we have by based on the position of the point, we can have a lot of values, right? That's why there is some formula, and by using that formula we got this is the we got the this as the maximum value. Okay, for the range of the float. And after converting this value into I mean after performing calculations, we got some value, and that is the maximum for the float. Okay, and in the last video, we also discussed the character and string, right? So I didn't like I forgot to tell how the data will be stored in the memory for the character. So we will discuss in this video. So for character, what will happen? The in Java it consumes 2 bytes, okay? And in other languages like C or any Python, any language, it only consumes only 1 byte. Why in other language like C and C++, it only consumes only 1 byte, and why it consumes 2 bytes in Java? Because uh, like in other languages, we have only minimal symbols, like minimal characters. Like if I open here the ASCII value table. So what is meant by ASCII here? ASCII means like American Standard Code. Okay, so it is used for the interchanges, the communication. So for like in the earlier days, what they done is like they don't like we can't send the characters, right? Because characters does not have any like the characters can't store in the digital way. That's why we can't transfer. But after that we have some ASCII values, which means for every character, for every symbol, we have some mapped in integer number. So based on that integer number, we can encode that data in the binary format, and we can store in the memory, and we can simply transfer the data. So here we have the ASCII value starts from 0, and it will ends with 127. Okay. After this, we don't have any ASCII values. Okay. And later, what I done is after like some years, what I done is they extend the ASCII values for the remaining values. Okay. So again, they extended to 255. So here you can see. So the ASCII values, the ASCII range is 0 to 255. So which is totally 256. Okay. And how many values we can store in one byte? So we can store in 1 byte. So we can store 256 values in 1 byte, right? Because 2 power 8. Okay. So like this we can store. But in Java, it supports like more characters. Like apart from these Apart from this English alphabet, it also supports the alphabets from the other language like Hindi, Telugu, Tamil, everything. Okay, and we have some unique symbols and special symbols. That's why it consumes 2 bytes. And like in other languages like C and C++, the characters will be stored in the format of ASCII values because they have some every character they have some mapping integer number. So that's why they can store in that format. But after 127, I mean from 256, we don't have any ASCII values. I mean we don't have any mapped character. Then how Java will store the remaining alpha characters? For that, we have Unicode values. Okay. So what is Unicode? For every symbol there is some unicode value. Okay, and how the unicode will be backslash on some hexa number. Okay, 001 or 002 or uh, 20ac, like that we have a lot of numbers. Okay, and this is the hexa number. So what is hexa number? So in the hexa number we have totally 16 characters. From it will start from 0 and it will go up to 9, and remaining values like we can only like in the numbers we have only 0 to 9 only, right? So what about remaining? So that's why they use the English alphabets A, B, C, and up to F. Okay, so it is totally 16 characters. That's why by using these symbols and numbers, they used to represent any number, just like binary. How like how we are doing that same way, they are converting the decimal number uh, into hexa, and they are using. Okay, and suppose I'm storing some value like in the alphabet. Okay, like for that, suppose the value in like the value is 2345. Okay, so now we need to convert to 2345 into some format, into binary format, so I can hold this value in the memory. But if I convert this 2345 value directly into binary, I can get sometimes 3 bytes, sometimes 4 bytes. Okay, and it's very difficult to store the data. So for that, what we have is we have some encoding methods. So usually we have, apart from ASCII, we have some UTF encoding methods. So we have UTF-8, UTF-16, and UTF-32. Okay, there are three encoding methods we have. So what we do is it will encode the hexa number into binary, and it will store in the memory. Okay, so how UTF-8 will work? So so based on the hexa value, it will convert the data into binary, and the range will varies from 1 byte to 4 bytes. Okay, and for UTF-16, it it will like any number will be converted into binary, and it last it will give only 2 bytes, and in UTF-32 it will give 4 bytes. Okay, suppose if I have any value like 2345. Okay, this value will be converted into binary, and the UTF-8 will give, suppose 3 bytes it's giving. Okay, but UTF-16, what do you do? It encode the data, and it will convert some value, and that value will be converted into binary, so I can expect that value in 2 bytes. In UTF-32 it will convert into 4 bytes. Okay, so in Java the size of the character is 2 bytes. That's why in Java internally by default we are using UTF-16 to convert to for encoding the characters, and after encoding we can store that value in the memory architecture. Okay, so this is how the characters will be stored in the Java. And if you like this video, please like, share, and subscribe.